Happy Tuesday everyone, it's Thijs from Varnish Software and I'd like to welcome you to yet another episode of 2 Minute Tech Tuesdays, that weekly show about Varnish technology presented to you in 2 minutes or less. This episode is about a relatively new feature in Varnish Enterprise called the transit buffer. 2 minutes is what I'm going to put on the timer and I'll try to explain it in 2 minutes give or take. Let's go. The transit buffer is a Varnish Enterprise feature that paces backend fetches. This is typically used for fast backends that serve large, uncacheable objects that are consumed by slow clients. And the attempt here is to reduce the memory consumption in Varnish while that happens. What the transit buffer does is match the pace of the client while fetching, and only store response data from that fetch in transient memory at the pace that the client can consume it. Without a transit buffer, a request for a large uncacheable file will be sent to the origin, and as the origin responds fast, Varnish temporarily stores the full payload in memory, transient memory that is. If this movie.mp4 file is 5 gigabytes, 5 gigabytes of memory is held as this slow client is consuming it. And as the data is sent over the wire, transient storage slowly drains, up until a point that when the response is completely consumed by the client, the transient storage is empty again. With the transit buffer enabled, Varnish can reduce the amount of memory that is held in transient storage to satisfy that uncacheable request. So when that same large uncacheable file gets requested, that movie.mp4 file, Varnish will forward the request from the client to the origin, receive it, and as it receives, will notice that the client is slowing consuming it. It will then slow down the fetch and make sure it's ahead in terms of what it is storing in transient storage of the client, but not by too much. If you set the transit buffer to a megabyte, up to 1 megabyte is kept in transient storage under the form of chunks and is continuously sent to the client. For example, 512K at a time, while another 512K is fetched at the same time. What we want to do is keep enough data in the transient storage to ensure that the client doesn't have to wait. So it's a balancing act. We can enable the transit buffer by setting the transit buffer runtime parameter to a value. In this case, that's 1 megabyte. And that means we're staying up to 1 megabyte ahead of the client, but not more. You can also set it on a VCL level by setting bresp.transitBuffer to a value of your choice. That was it for this week's episode. Just like all things in life, using the transit buffer is also a trade-off. On the one hand, we try to keep memory consumption in the transient storage as low as possible, and on the other end, we're not trying to tie up the fetch for too long. And before we end, an interesting remark about the transient storage is that it's usually not limited in terms of size. So that means if transient storage starts growing real quickly, your server can go out of memory. Transient storage is used to keep track of short-lived data that doesn't end up in the normal caching storage, but also uncacheable data that needs to sit somewhere in memory while the client is fetching it. So thank you again for watching this week's episode. We'll surely be back next week with more.